Hello, everyone. I just want to give you a little help with your final project. You may have already, you probably have already started on it. You may be nearly finished, but if not, if you're struggling, maybe this will help. Now, what you see here is the code running, and let me show you. I have notice the blue light is solid. That means the state is cooling system on, but we don't need the cooling system at the moment because the ambient temperature is less than or equal to the desired temperature. So I'm going to raise the desired temperature by clicking the red button. And notice now we're still in cooling, but the blue light is pulsating. So that means that we raised the set point, and so the blue light is pulsating, meaning the cooling system is on. So let me show you something here. We'll take a look at the code in a minute, but first I want to point out when you're wiring up those last couple of buttons, you should already have one button in place and working for your original button test for module 6. If not, then you'll be doing that this week too. But the two buttons that you're going to wire up now, the instructions say to use the numbers on the left-hand side. In some cases, it specifically says that. In other cases, it specifically says to use the numbers on the right-hand side. So just remember, when it says left hand and right hand, you want to get oriented on this T for your breakout board. So when you're looking up at the breakout board at the T, that defines your right and left side. So over here is going to be your left, and over here is going to be your right. So for example, on the jumper here, it says to put it into row 21, column H. So even though the column it talks about is over on the right-hand side, column H, the number, the row number that you want to go into is, you have to look over here on the left-hand side to get the row number. Oh, for the other one, both the column and the row are on the right-hand side, so that one's a little simpler. But just remember, you're going back and forth between numbers on the left-hand side and right-hand side when you wire up these jumpers. But the column, for the rows I got to be in the left-hand side, sometimes right-hand side, but the columns, in this case, are both on the right-hand side. And I know that's a little added confusion, but I just didn't want you to wire everything up wrong. And then, because there's so many jumpers on here. This is, by the way, this is a spare breadboard that I have just to show you this. Uh, but as I showed you, the real working board is over here, and you see all those jumpers. If you get a couple of them wrong, it's very difficult to trace them down with so many wires around there. So want to you want to follow those instructions very carefully. Now, in your code, you've got some to-dos. They gave you a very nice starter code file, the thermostat.py in module 7. And so they gave you some to-dos. So let's go, for example, I believe there's a to-do on line 262, roughly. Actually, we sort of are one off here, but in the on enter heat, you need to enter that, the self update lights call. It's a function call. And also, we're going to be actually implementing some code in update lights. And you have a little bit of logic to code in there, but most of these to-dos are method calls, and in two places you have some logic to do. So what else do we got? 264, that's more of the same. Red light off. Actually, that's 275 probably, and then probably around 277. I don't see my line numbers here, but I'm looking at another monitor. I'm looking directly at the actual console on the Raspberry Pi, where I did a search of all the to-dos in the original sourced starter code. And so this is the solution, and this is what you have to put for those in place of those to-dos. And it says to remove the to-dos afterward. That's up to you if you want to leave them in, just in case something's broken. Then unless you inadvertently changed some existing code, you can just focus in on finding the problem where those to-dos are, because that should be the only place you've made any modifications to the file. So then here we're going to, on exit cool, we're going to turn the blue light off, because if we've been in cool state, we're going to, we know that the blue light was on and we're leaving the cool state, so we turn it off. Cycle, later on you're going to be sending the word cycle to the state machine, and this is what it does. It's just going to go, if we're in off, I think we're going to go to heat, and if we're in heat, we're going to go to cool. If we're in cool, we're going to cycle back around to off. And that's with that first button you installed last week is going to do that. Then the two new buttons you're going to put on, all they do is increase or decrease the desired temperature. And then every time you update the lights, it's going to check the ambient temperature, room temperature, as read by your temperature sensor, and it's going to compare it to the set point. Now, I want to mention too about the temperature sensor. It was a challenge getting that on, because what happened to me is I when I originally put it on, I didn't. I think that was one of the first things we did when we were assembling the Raspberry Pi, and we just put that little um, shim uh, down. We seated it on some of those pins, GPIO pins, and then we put the ribbon on the pins and started working on other stuff. 6 weeks later, we come back and we actually have to use the wire that's hooked up to that shim, and it doesn't work in my case. So what I ended up finding was you got to look carefully. Get the magnifying glass if you have one. If you don't have one, you might want to get one if you're going to be doing this kind of thing. Because the shim was very tiny, and the holes in it are very tiny. So I hadn't, if you recall, one set of holes has like a metal ring around it. Well, that's the only set of holes I saw. There's another set of holes too in front of those, and so I'm working from memory here, but I believe that's right. But anyway, I just focused in on one set of holes. But actually, it has to go on both rows of the GPIO pins, not just the outer row. And so it was never working. The LED wasn't lighting up on the sensor. It wasn't getting any power. And I saw it on bus 20, but not bus 1, where it should have been. And when I tried to run the test code, of course, it didn't work because it couldn't find the device at position 38, where it was expected. So anyway, just be careful of things like that. It's not a big deal if you need to go back and, first power off your Raspberry Pi, unplug it, just lift off the ribbon. This is if your temperature sensor isn't working. If the code can't find it and the LED isn't lit, then chances are you don't have it properly seated on both rows. Down at the end, like the last three rows. I should say both columns, and then the last three rows. So just don't want you to spend as much time as I did figuring that one out. So anyway, that's the cycle. And then in these to-dos, mostly it's method calls like this, but let's go on down to update lights. And here you have a big to-do section. I think they give you this part, and they probably give you this part, but what you have to code is right here under, well, you'll see a big to-do there, but it's determine visual identifiers. So if the current state is heat, we're going to, we know that the heat is on, so rather the state of the thermostat is in heat mode. Doesn't necessarily mean the heat's on. Depends on the comparison of the ambient temperature to the desired set point. And so if the if the state is heat, then we check the temp, that's the ambient temperature in the room, to see if it's greater than or equal to the set point, the desired set point that you can increment or decrease by those two new buttons. We're going to check, and if it's already as warm or warmer in the room than the desired set point, then we're just going to turn the red light on solid. Else, if the temperature is not at or above the desired set point, then we're going to make the red light pulsate, just like I showed you the blue light is pulsating on mine right now. So back to the outer else, if else, for the state, if the um, current state is cool, then we're going to, we know that the user has cycled to the cooling state. So we're going to check if the temperature is less than or equal to the desired set point. Then we're going to just turn the blue light on solid, because we don't need to actually actively cool the room, but the user wants it in cooling mode. So we turn the blue light on so they're aware of which mode they're in. But if the temperature is, if the set point is greater than the ambient temperature, then we're going to pulsate the blue light, which is what is going on mine right now. Else, so remember there are only three states: heat, cool, and off. So if it's not heat and it's not cool, then it's off. So we're just going to pass. Because remember, up top here, the first thing we did is we turned off both lights. And then we determine which one, if any, to turn on and whether to pulsate it or make it solid. If we're not going to do anything with the lights, we just pass. And that's like a return. So then what else do we have to do? My screen went dark up on the Pi. Anyway, so now manage. Now notice most of this code up here is driven by interrupts, by button presses. Now down here, this is your task scheduler. So this is, notice this loop, while not end display, and end display is, I don't see it here, but it's, I'm sure that is interrupt driven. You know, you hit Control C, keyboard interrupt. So until that happens, this task scheduler loop is going to run continuously. And so, and we're going to, every time through the loop, we're going to get the current time, date time, and then we're going to display that current date time. If you're watching your LCD and you're running this code and you've got everything wired up correctly and your code is all correct, then you'll see the time change every second. Because notice down here we have a sleep for 1 second. So this is going to loop through, I suppose, every second. And then it's going to get the current time and display it. And now here we have notice we have a counter and an alt counter. I believe the alt counter, it looks like that is for updating the lights. And Also, if the alt counter is less than 6, we just want to display the temperature. And if it, yes, I was looking at it. So if we've been through the loop fewer than 6 times since the last time we reset the alt counter, and where do we reset that? Right here. Reset it to 1. So if it's less than 6, and then we only display the temperature on line 2. If it's greater than 6, if we've been through 6 times or more, if it's 6 or greater, then we get the current state and the set point. So you see, we're either displaying just the ambient temperature in the second row on your LCD, or we're displaying the state and the set point. And then after the alt counter reaches 11, in other words, after we've been through the loop 11 times, then we're going to update the lights and we're going to reset the alt counter. And then we update the screen. The LCD, that is. And then every 30 seconds, if the main counter is evenly divisible by 30, because it looks like we're not resetting the main counter until you kill the program and start it again. So every time this main counter is divisible by evenly divisible by 30, this is the modulus operator, of course. So if you divide the counter value by 30 and there's no remainder, then it has been 30 seconds since the last time that was true. And so you want to update the server. And oh, wait a minute. It looks like we do reset the counter. So every 30 seconds, we update the server, reset the counter. You wouldn't actually have to do that because I think every 30 seconds, it would be evenly divisible by 30. So, the first time that would be true would be when it reaches 30, then when it reaches 60, then when it reaches 90. But they've done it that way here. That does keep it simpler and less prone to error. There could be some value in between that's evenly divisible. I have no idea, honestly, but that's certainly a safe way to do it. And then finally, clean up your screen display. This is when you come out of the loop, when this is no longer true. What else we got? Then I think we have some to-dos down here. So we got the green button, the red button, the blue button, and of course those colors depend on which color caps you put on the button. But I would recommend sticking with this as I did. I put a green cap on the button that's associated with GPIO 24, and that's the first button that you put on last week. The two new ones are, you know, the middle button is at GPIO 25, and the last button that you should be putting on is at 12. So the one at 12 is going to lower the ambient temperature, not the ambient, the desired temperature. The one in the middle is going to raise the desired temperature. And then the one at 24, the button at 24, is going to simply cycle through the states, heat, cool, and off. So I would go ahead and put the correct color caps on those buttons to match these identifiers. And that clues you into, excuse me, what they're for. So those are your to-dos. That's the code. It's still running. Now let's go ahead and kill it. And now it's cleaning up and exiting. So I really can't. I don't. But the camera here is a little far away from the breadboard and the Raspberry Pi. So, oh, that's right. My light went off because I killed the program. But I will include a little movie that I'll make from my iPhone just to sort of scan the wiring of my breadboard, show you the LCD working, all of that, so that if you're struggling with the placement of those wires, maybe that'll help you. We had some copy paste errors in those instructions a few weeks ago. I didn't see anything like that here because most everything is already wired up. You've got, I think, two additional resistors to put on, one for each of the new buttons, and then two sets of two jumpers for one set of two for each new button. And so that should be it. If you have any difficulty, please let me know. I recommend you post something in the general discussion so that we can all get a chance to help you out. And you might also, of course, if you put it in the general discussion post, I'll get an email notification that you entered something in there. So it's not necessary to send me an email in addition to that, but you're certainly welcome to. But if you drop it in there, I've got my subscription set up in such a way that it will alert me immediately. It won't wait for me to go in and remember to look in the discussion board. So that's it for this session. Good luck with this project, and let me know if you need anything.